Hi, my name is Roland and this is the second part of our DIY battery monitor build. And in today's part we are talking about the hardware components which we are using for this build. So let me show you what I have here on the table and what we can do with this. I had to re-edit this video because I initially thought I'm gonna do it with a nano on my adapter, but the nano turned out to have not enough memory also for this project, because we have a lot of libraries for the IoT stuff and Wi-Fi, so the nano was not sufficient for this job. So I have again switched to my most favorite controller, which is the Mega Pro. That's the reason why you will see some frames of the video are showing the nano on the adapter, but the final version of the DIY battery monitor is going as well to use the Mega Pro. Here are the items we need for this build. We have a box. It's a little bit oversized, but I could not get anything better. The other ones were too small. A project like this, you need some sort of a platform. I have my PCBs from my AC power wall. That board, of course, has features we don't need for this build, so we're only using those connections which we need. If you would use another microcontroller, you need just something what is connecting your components. So let's say you are using a ESP32 development board or something like this. You could just use a prototyping board and make some connection with jumper cables, or however you would like to do that, right? In my case, I'm just using my boards from the Powerwall controller, and that board was made for the Mega Pro microcontroller. This one, of course, is also much too oversized for this project. We have a lot of pins. We have about 60 GPIO pins, but we only need a couple of them. Most of our features are running on the I2C bus anyways. So, controller. Then we are using the ESP8266 in the version of the ESP01, the Wi-Fi module, and the ADS1115, a 16-bit analog to digital converter. This one we use to read out the battery voltage, which is done on the voltage divider on the board here. There's a 20 kilo ohms resistor as the first stage, and then 1680 ohms on the second. This is dividing the maximum of 59 volts down to below 5 volts, which we need. Here is the external watchdog, which we need because we want to use Wi-Fi, and the internal watchdog would be not sufficient for this kind of project. Still in the experimental phase, but the final version is already on the way. Then we have a display, and we have two connectors for temperature sensors, and then here two connectors. One is the voltage, total voltage, and the other one will be for the shunt. So we have a shunt. This one is a 100 amp shunt and 75 millivolts. Then we will have this sort of temperature sensor. This one is for inside the battery, and the other one you saw already last time on the inverter. Then we use a LCD display. This one is a 16 characters by the 2 rows. So I'm using this one because I had it already laying around. Probably better would be to use a 4-row display for this one also. So this one is the INA 219 sensor. We have to misuse this a little bit because this is designed to measure current up to 3 amps and then voltages to 26 volts. But we of course have a 48 volt nominal system, and our current is up to 100 amps. So we are using this only to read out the shunt voltage, and we have to install our shunt on the low side. This is meant to be installed on the high side to also measure the voltage, but this we are not allowed to do, otherwise we will just blow up the sensor. So only measuring shunt voltage and install on the low side and not use the voltage, bus voltage feature of this sensor. It should work like this, but we will see. For the power, I'm still waiting for a buck converter which will convert the 12 volts which I have already there down to a little bit lower voltage, because otherwise the microcontroller voltage regulator is getting a little bit too hot. That was it already for today's video. We were talking about the individual components we have to use for this build. All of this is just somewhere around $25. It's in the range of like a cheap Chinese battery monitor, with the advantage that we have Wi-Fi on the board, that we can of course anytime upgrade this with other features. Okay, so thank you for watching today's part. Please like, subscribe so that you don't miss the next one, and I see you on the next part.